Okay, this lesson is the review from day 2. Okay, so again, we start off with a little matching activity. Intersect once, that's going to be one solution. These are parallel lines. They will never intersect, so that's no solution. This is infinitely many solutions. We have one line on top of each other, the same exact line. And then our last one, the lines don't look like they intersect, so a lot of people are quick to say no solution. But if you kept going, they would intersect once. So that would be exactly one solution. So these will intersect. They are not parallel. That's the only way it's no solution is if they're parallel, and they are not. You can tell they're going to intersect. Okay, so then this lesson is reviewing elimination. Okay, so in the first set of systems, they're lined up really nicely, and it looks like when we add these two equations together, our x's are going to eliminate right away, so we don't even have to multiply by anything. And then let's add together our y's. 3y plus 1y is 4y. 28 plus 4 is 32. Solve for y. And we get that y equals 8. Okay, so that was our first thing that we had to find. Now we need to go back and find x. So let's rewrite one of the originals. I think the second one is easier to work with. Since there's an invisible 1 for a coefficient of y. It's not being multiplied by anything else. All right, so let's plug in our 8 for y and solve for x. Minus 8 on both sides. Negative 2x equals negative 4. Divide by negative 2 on both sides, and we determine that x equals positive 2. So that means our solution is 2, 8. Okay, I will show you the check for probably just this one, so you know what to do, but you can do it on all of them, especially on your test. I'm going to rewrite both originals. Rewriting both originals. Plug in 2 for x and 8 for y, because that's what we said our solution is. 2 for x, 8 for y, and see if it checks out. So you could just put this whole thing in your calculator. 2 times 2 is 4, 4 plus, and then 3 times 8 is 24. 4, I'll just do it step by step. 4 plus 24 is 28. So that does check out. Okay, and then here, negative 2 times 2 is negative 4. Negative 4 plus 8 is 4, so that one checks out as well. So that's how we know that that solution is on both of those lines. It's where they intersect. Great, the second one. Okay, we have some additive inverses that are going to cancel out and eliminate right away. 4y minus 4y, excellent. 3x plus 5x is 8x. 10 plus 6 is 16. Divide both sides by 8, and we solved for x to be 2. Great, now we need to go back and find y. Okay, we found x, let's find y. Rewrite one of the originals. Plug in 2 for x. And solve for y. 3 times 2 is 6. Let's minus that constant on both sides. And then divide by 4 on both sides. We know y is 1. Our solution is x comma y, so 2 comma 1. Okay, number 3. We don't have any additive inverses that are going to eliminate right away, so we're going to have to create them. So let's look at this 2 and this 5. 2 times 5, well, I know that that's 10, so we can make those both into 10 and negative 10. So kind of like a trick here is to multiply this one by the number here, 5, and this one by the 2. And then you need to make one of them negative, so we have a negative 10 somewhere. So let's just make the first one negative. Let's multiply everything by negative 5, and then everything in this equation by 2. Our new equation up top is going to be negative 10x minus 15y equals, let's see, 15 times negative 5, negative 75. And our second equation is going to be 2 times 5x is 10x, 2 times negative 2y is negative 4y, and 2 times negative 29 is a negative 58. Let's add these two equations together. Our x's are going to cancel out. Negative 15 plus negative 4 is going to give you negative 19y equals negative 75 plus negative 58, negative 133. Divide both sides by negative 19. And we determine that y is 7. Now we need to go back and find x. Rewrite one of the originals. I think the first one looks easier, so I'm going to pick that one. Plug in 7 for y. And solve for x. So 2x plus 21 equals 15, minus 21 on both sides. 2x equals negative 6. Divide both sides by 2. X equals negative 3. And then lastly, write your solution as x comma y. Okay. Number 4, we don't have additive inverses, so we need to create them. All right, let's see. We can multiply everything in the first equation by the 3 we see down here. And we can multiply everything we see in the second equation by the 5 we see up there. That would give us 15x and 15x. Those are not going to eliminate. We need to make one of them negative. So I'll just make the first one negative and let's distribute. Our new equation, negative 3 times 5x is negative 15x. Negative 3 times 4y is going to be negative 12y. And negative 3 times negative 14 is going to be negative 42. Second equation, 5 times 3x is 15x. 5 times 6y is 30y. 5 times 6 is 30. Add these two equations together and elimination will occur. Our x's are going to cancel. We're going to be left with 18y equals negative 8. Let's see. Negative 42 plus 30 is now negative 12. My bad. That's why we use our calculators. And negative 12 plus 30 is 18. Okay, let's just double check that. So that's negative 15, that's negative 12, and then 14 times 3, 42, 15, 30, 30. All right, then we divide both sides by 18. Negative 12 divided by 18. We're going to get the fraction negative 2/3. All right, sounds fun. Now let's solve for x. Okay, so let's rewrite one of the originals. I think the second one's probably easier. Let's plug in negative 2/3, yikes, for y, and solve for x. 6 times negative 2/3 is negative 4. Again, just use your calculator. Add 4 on both sides. Oops. Divide by 3 on both sides. And you're going to get 3 1/3. Our solution is x comma y, so 3 1/3, comma negative 2/3. All right, right, we got 2 more and then a word problem. All right, number 5, we want pairs that will eliminate. So let's just continue working with our x's. So I can multiply by 10 and then multiply by 4. Just kind of flip-flop those numbers, and then you think about the signs. This one's already going to be negative, and this one will be positive, so they'll cancel. So we're going to get negative 40x minus 20y equals 140. And then our second equation is going to be 40x plus 28y equals negative 100. Let's add these 2 equations together. Our x's will cancel, and we'll be left with 8y equals 40. This one is working out much nicer. Divide both sides by 8, and we get y equals 5. Awesome, we found y. Now let's go back and find x. Rewrite one of the equations. I'm going to pick the second one. It doesn't have as many negatives. I'm going to plug in 5 for y. And then solve for x. So we get 7 times 5 is 35. Let's minus 35 on both sides. Then we'll get 10x equals negative 60. Divide both sides by 10 to determine x is negative 6. Our solution is written as x comma y, so negative 6 comma 5. All right, number 6. We don't have any additive inverses, but we can very easily make this one into a negative 6x to cancel with the 6x by multiplying by negative 2. Then we'll have negative 6x. Negative 2 times 4 is going to be negative 8y, and negative 2 times 10 is negative 20. Rewrite the second equation. Add them together. Our x's will eliminate. Oh boy, our y's are also going to eliminate. And then negative 20 plus 20 is also going to be 0. So when you have to put your placeholder of 0, and 0 does equal 0. So that means infinitely many solutions. These two are the same equation. And if you look more carefully, the second one is just twice as much. It's just double the other one. Right? 3 times 2 is 6, 4 times 2 is 8, 10 times 2 is 20. So it's just doubled. Okay, and lastly, we have a word problem. Manny brought 3 tacos and 4 orders of nachos for a total cost of $12.50. So I'm going to highlight Manny's purchase in yellow. Sean bought 3 tacos and 2 orders of nachos for $8.50. Let's highlight his in pink. Let's write our legend. We're trying to write a system that can be used to determine the price of a taco and the price of an order of nachos. So we need to figure out the price of a taco. So T can represent the price of a taco. And then N can represent the price of an order of nachos. Okay, let's make our 2 equations. Or 2 systems. Okay, our system. All right, so we've got 3 tacos plus 4 times the price of the nachos totals to $12.50 for Sean. I'm sorry, for Manny. And then Sean has 3 tacos plus 2 orders of nachos, and that totals $8.50. Okay, this is our system. I'm going to rewrite it over here to solve it. 3t plus 4n equals $12.50. 3t plus 2n equals $8.50. Alrighty, we need additive inverses. Our t's are almost ready to cancel out. One just has to be negative. So I'm just going to multiply everything in the first equation by a negative 1. Then we have negative 3t minus 4n equals negative $12.50. And then I'm going to rewrite my second equation. Then when we add our equations together, our t's will eliminate. We add our n's together. Negative 4 plus n plus 2n is negative 2n. And negative $12.50 plus $8.50 is negative $4. Divide both sides by negative 2, and we determine that N, so the price of nachos, is $2. Now we have to find the price of a taco. So let's rewrite one of the originals. I'm going to do the smaller one. 3t plus 2n equals 850. Let's plug in 2 for n and solve for t. 2 times 2 is 4, minus 4 on both sides. Three t equals 450. Divide both sides by 3. And you're going to get $1.50. Let's see. I'm going to write our sentence up here. The cost of a taco is $1.50. The cost of an order of nachos is $2. And that's our full sentence. And again, you could check this by plugging in 150 for T, 2 for N, and making sure it balances for both of their orders. Okay, thanks for watching.